All right. So since we are already in time, actually beyond time, so let's get started. Today we are going to do tutorial workshop on robot operating system, often known as ROS. Um, ROS is like one of the most popular robotics framework, um, which is basically a very advanced and rich environment uh, for networking between different functionalities in your robotic system. So as you already know, a typical robotic system consists of a lot of modules, right? So let me quickly pull up a autonomous driving autonomous vehicle thing, for instance, right? Let's see. Let me see if it's a familiar one. Sorry? Oh, sure. I'm just picking one image and then yeah, you can look at this one maybe. Come on, of course. There we go. Now I'm verified. Okay, so for instance, look at this. There are so many components, for instance, for perception, localization, mission planning. Planning has like different modules, mission planning, behavior planning, and then motion planning. Then comes the control part for tracking a trajectory and tracking a path, essentially. And these all modules communicate with each other, share information with each other to kind of make everything work in a loop, right? So all these modules, including like from the sensor, you get the data, right? And then you process the data, you get the information out of it, you merge the data from different sensors like LiDAR, camera. LiDAR is like a 3D scanner for the environment. You merge all that data to come up with a perception of the environment, which you use for localization, essentially finding out the position of a car in a particular map environment. So and then comes like later parts like planning, different kinds of planning, and then control part. All these need to be implemented in some way programmatically, right? So one way is to do traditional way, just start writing a file and keep writing your program in one single file and keep like sequentially do everything. But as you can assume, each of the modules have like 50 files in themselves, and that's like a very bad approach. That's where the frameworks like ROS, robotics frameworks like ROS come in picture. They give you modularity to your code, to your entire framework or whatever system you're developing. It's not limited to autonomous vehicles. It can be any home robot, even the what's that home robot called Roomba. They initially started with using ROS, and now they I think have their own thing similar to ROS, but trimmed down so as to make it efficient. But what I'm trying to say here is to make all these modules communicate among each other, make them modular, so that if one breaks, the other still has some functionality that is still working. We need a much modular framework than writing sequential codes. So that's why we are studying ROS, because it gives us that freedom to kind of have a distributed system for the entire framework that you're developing. You can have a distributed system. You can have modules running, and they're communicating among each other, publishing data, sharing data among each other, and then processing it, and then sharing it again to someone else. So that's where ROS comes into picture. Now, I told you about the use case of ROS. Now let's look at the structure of how ROS works on a very high level. So all of you are aware of YouTube, right? So how does YouTube work? I have a channel, I have a few subscribers, and now this channel, if you can subscribe to my channel, right? As so you will be called a subscriber. I have a channel, you subscribe to my channel. Now, whenever I publish something on my channel, you all get a notification that, okay, there was a video published on this channel. If you, of course, you have that ring thing enabled, but you essentially get you all of my subscriber will get a message that, okay, there was a new video published. So this paradigm is not new. It's a very old paradigm, publisher subscriber. Okay, let's quickly look at ROS publisher subscriber paradigm. Basically, there should be a very nice image here, right? For instance, let's look at this one. Can you see it? So here the topic basically becomes my YouTube channel. Okay, I'm just giving an analogy, but this is definitely a lot more complicated. So I'm myself as a person is a node. You all as a person, you are also nodes. And there's this channel which is here called top, right? So I publish something, all of my subscriber get that message. You understand? On a very high level. So here I'm only showing two nodes, but this can get really complicated. For instance, I have an image somewhere here. Oh, there should be here also. Yeah, you see this? The message was published. Both of the subscriber get the message, right? So they share the message through the topic. That's very important to know. So there are basically three entities here. There is a publisher, there is a topic, and there is a subscriber. Okay. You see, there comes a new publisher, and it publishes, and whoever is subscribed to that node will get the message. So this is on a very high level how ROS is structured. So you can imagine now, for whatever robotic system you're developing, you can have like a LiDAR data being published from here, and whoever in your system needs to process that LiDAR data, get information out of it, can subscribe to that LiDAR data and basically process whatever information they get and come up with some more meaningful information added to the LiDAR data and publish it to another topic. And in this way, you can go down and down to a very low level where you're basically controlling your vehicle from getting the data from the sensor, and now you're actually publishing some velocity and throttle inputs to your vehicle, right? And then you can again get a feedback. Who is that? Is there someone on Zoom? Okay, never mind. So let me, okay. I think it's Nishi actually. Is it your laptop? Okay. Any questions so far? Can you be a little louder? Yes. Topic. Yes. Of course, a node can publish to multiple topics. Yes. So getting back to, oh, did I answer your question? Okay, awesome. So this is how ROS is structured internally. This is only one thing that I mentioned. There are more communication formats other than publisher subscriber. There's services, clients, there's action. But we are not going to cover those advanced topics in this workshop. We'll keep it for maybe next ROS workshop. Okay, so we'll have more advanced workshop on ROS in the future. So as I was saying, this can get very complicated actually. Yeah, you see that? This is one of the one of the robot model. I don't know which particular model is this, but some application, robotics application, they're using this this graph. So when I say nodes publish over topics and then there are subscribers, this all can be can all be shown to you in ROS using RQT graph, which I'll cover. Okay, we'll look into one of the very popular tutorial in ROS, and we'll ourselves start a node or create a topic and then see for ourselves what is what. Okay, so it will make it more clear. Lines are topics, subtopics. Okay. Yeah. Anyway, it can get very complicated basically. So what I want you guys to do now is open your VirtualBox or VMware, whatever you're using, First thing first, install VS Code because it's not already installed. Just Google VS Code download. Go to downloads, download the DEB file. Okay, should start download. Just save the file to its default location. Are you guys with me? All good? And open that folder, okay? So that folder should be open here for me. I already have one version installed. So what you want to do now is to install it. Is it better? Looks good. So what I want you to do to install this is go to your download folder, right click and open in terminal. It will pop up this. So as you can see from the last Linux tutorial, I told you like, you will see the path where you are currently here, right? You're in downloads. Tilde basically means your home directory. Okay, now just do sudo dpkg flag I, which means install. Okay, and just write code and press tab. It should auto complete everything, right? Just write code and press tab. And it should just give you this and then press enter. Enter password 00 for the virtual box. It's already installed for me, I think, but yeah. Awesome. All right, so ROS has already been set up for you in this VirtualBox image. It's already installed. The version that we have installed is Noetic. For anyone who wants to do a fresh installation, just Google install ROS and should bring up this page, right? You can select version based on what Ubuntu version you're using. So this one is recommended for 18, this one for 2004. Go to that and click Ubuntu and follow these instructions to install it. So most important one is basically this. This will do a full installation, but you can do installation without visualization libraries also. But they are important. We'll see some visualization also. All right. Next thing, what I would want you to do is open your files. Okay, go to your home directory. Okay, go to your catkin workspace, right click, open in terminal, and write code dot. What this will do is it will pop up VS Code inside this directory. So it will basically open the entire catkin workspace folder inside your VS Code. So I already have it open, but it should open empty for you like that. This we'll be using this for your code editing throughout this tutorial. All good. All right. So before I move ahead with the catkin workspace, I just want to show you quickly how you can create this. So what this means, a catkin workspace. So this is like a workspace for ROS where you will store all your packages that you develop for your robotics application. So everything goes inside this. Whatever you build from here on in ROS, it should be placed inside catkin workspace. So that's the little organization that ROS follows. You can name it anything, but this is very standard. You'll see it in every tutorial. Now, when you create catkin workspace, it should be empty, right? What you should do is basically create a source folder here, src, okay? And inside this, you should open your terminal. And for the first time, for now, I have already all these packages, right? But for the first time, you want to create these packages. So what you want to do is create catkin create pkg. That's the command for ROS to tell it that I want to create a catkin package. Okay, catkin is a build command for ROS. So when you write your programs, catkin is used to build all those programs. Just like in C++, you have CMake, right? That's how you have catkin here. So you want to create a new package in ROS. You want to use this. and let me just write my name. Okay, and so this Nitish is my package name here. Okay, or let me make it a bit meaningful. LiDAR code, for instance, right? LiDAR code. This is this first argument is my package name. The next argument is all the dependency that this package has. So I'm going to program in Python, right? So you should be writing ROS.py, and this whole repo, that whole package that will be created using this command will have ROS.py available to be used. Okay, so I'm just going to add that, and you'll see a new folder created here, which says LiDAR code, which is my package, right? And everything should be pre-configured for you, even including the source folder where you put all your code, right? And if you open these files, you'll see what packages you gave as dependency will be placed in this. So if I scroll down, I should be able to see ROS.py dependency added automatically. You see this? Don't need to understand how this is created for now. Once you start working with ROS, you'll get a understanding of that also. But for now, just understand, to create a new package in ROS, you need to go to your Catkins source folder, right? Catkins source folder, and inside that folder in your terminal, just write this command, whatever your package name is, and the package that it depends on. So what I want you guys to do is, in your virtual code, VirtualBox, is there a beginners tutorial folder existing there? Inside Catkins source, is there a beginners tutorial, beginners underscore tutorial? There is. So what I want you to do is right click here outside. Don't go inside beginners tutorial yet. Just open in terminal here. Okay. Right click and open in terminal. It should get you to this path. It does. Okay. Now what I want you to do is RM, which stands for remove, which we covered in the last tutorial. I want you to do RM RF, okay, RM RF, and do beginners tutorial, and then enter. So this will basically delete that beginners tutorial. Okay. Also, I just want to add this very important thing here. In Linux, use tabs as frequently as possible. Tabs are your friend. They will auto-complete for you. Whatever you're thinking, it will suggest. If there were, for instance, look at that. We have multiple folders starting with turtle, right? In this folder, you see all these folders start with turtle. So if I write turtle, TUR, and I press tab, it completes that turtle. Now it needs a break. Which folder am I referring to? For instance, I don't have this GUI access, right? I cannot see it. I just press my tab key twice, and I see all the folders that are in there, right? So this is very handy when you are working with the terminal. So I can just write turtlebot3. Now it auto completes till turtlebot3, but there are 3 folders with turtlebot3. I press underscore, right? There's still 2 folders. So tab will break your like similarity based on the character that you enter next. Anyway, since you removed the beginners tutorial previously, what I want you to do now is do catkin create pkg again, right? And then just write beginner tutorials, right? This and this, and then just write ROS.py. Okay, so far so good. And then write string. Hold on. Let me make sure that the std messages actually. So just write std messages. So I'll explain in a bit what this means. This is again a dependency that we are going to use for this package. So make sure you add that. Okay, make sure you add ROS.py and std messages. Okay, these are the 2 dependency that will be used for this beginners tutorial folder. All good? So it should basically create this folder again, which you just deleted. It should create this folder with all these files inside, except for scripts. And I think include also. So it should basically add this, and source folder. So it should basically add these 3 files for you, right? Just peek into that folder by using ls beginners tutorials. So you'll see everything that's in there actually. So we are in the source folder. What I want you to do is cd to beginners tutorial. Okay, cd to beginners tutorial. Now I'm inside beginners tutorial. I can see my 3. So ignore this include and source for now. Just sorry, you have this file and the source. So what I want you to do is create a new folder called scripts. Okay, do this mkdir scripts. And then once you have done this, just do a quick ls and to check if scripts is already there. For me, it was already there, so I'm not doing it again. All good? Am I too fast? So whoever is not able to type these commands, please take notes so you can work on this whenever you get back home on your laptops or desktops.
We'll also be uploading the recording.
Yes. Yes, we'll upload the recording as well. Anyway, so I was in the beginners tutorial folder. I did my ls. I see my scripts folder, right? Go to that scripts folder now. Okay. Now I have 2 files here already, but you won't have it because you just created the script folder. What I want you to do is now go to this link. Go to this link, github.com NITESH4146. Can you guys see it? Okay. Open the scripts folder. Okay. And I want you to grab the Docker file. Just copy maybe from here. Just copy this code. Okay. And next thing I want you to do is in your scripts folder, you're already in the scripts folder, right? Just to touch listener. In fact, actually, do you guys have VS Code open? Okay, so do this. Open the source folder, go to the beginners tutorial. Okay, let me close this. Okay, inside beginners tutorial, inside script, it should be empty for now, but click on it and click the new file. Okay, click the new file and just name it listener.py like that and press enter. Okay, now you have this file. What I want you to do is just paste everything that you copied from the GitHub into this listener.py. So basically you should have your Catkin workspace, your source, and then your scripts. And then inside that, you should have one file called listener.py. Okay. Now create another file called docker.py in the same folder. And you should have now 2 files, listener.py and docker.py. And I want you to do is go back and open the Docker file. Okay, copy everything and just go ahead and paste in the Docker file, docker.py file. So far, so good. So basically now I have 2 different files. One is called, are the same? Did I grab the same? Oh, shoot. Let me grab the listener. So listener goes to listener, Docker goes to Docker. Okay. All good so far? Have you guys created the 2 files? Okay, awesome. So next is open that folder again where you were in the scripts folder, right? So you can just do pwd and see. Actually, you can just look here and see where you are. So you are in scripts folder. What I want you to do is do chmod +X, because by default these files will not have permission to execute using your ROS run. So to make this visible to ROS, what you want to do is chmod plus X, and then the two files, you can just add them here like that. Okay, and then press enter. So now both of those files should be in green. Before, if you did ls, they will be white. Now they should be in green, basically meaning that you have given permission to them. Okay, so good. So far, so good. Okay, awesome. Now what I want you to do is go back to your Catkin folder, Catkin workspace folder. Just do cd tilde and then Catkin workspace. Let me zoom in a bit so that you guys can see it. Okay, so do this, and you should be transferred to the Catkin workspace. Okay. Now next thing is very important instruction, which is called catkin make, catkin underscore make. This is when you build all your packages that are placed inside your source folder. So you do this, and basically it should compile everything and find all the dependency, connect everything together, and make everything visible to us. Okay. So far, so good. Now, what I want you to quickly do is, yes, Catkin make. To do what? To build it, go to Catkin workspace first, and then do Catkin underscore make. And it should basically build 100% of your packages. There should not be any error. Sure, sure. Yeah, it might take some time depending on your system. And first time if you build it, it does take some time. I have like built it previously, so all good. How about the person in the back? All good? Awesome. So we have our packages built. Next thing is to make these packages visible to ROS. We just built it, right? We want to make it visible to ROS. So we want to do source devil. So this line is called popularly as sourcing the devil, but it's just to remember, after you build your Catkin package, you just need to do source devil slash setup.bash. When you do this, all your packages that were just built by Catkin are available system wide. So from anywhere in terminal, now you press tab, it will autocomplete. So it will able to find. All good so far? Have you sourced the package? Right. So when I wrote source, I wrote only D, and then, okay, God, so there are some people online. Okay.
So I'm checking to see the audio.
Okay, Andy is here. Hi, Andy. Okay, so I have done sourcing the devil. I'm going to do it again just to show you. Okay, now there is a command. So now is the stage where we run our nodes. Okay, this is where you'll see the communication between nodes via topic actually happening. Okay, and we'll also look at the RQT graph for that basic function. So what I want you to do is to run a node in ROS. What you want to do is do ROS run. Start with ROS run, and then what was your package name? Anyone that you just built? The package name. Beginners tutorial. Perfect. So you remember your package name, right? Just do ROS run and just write BEG and press tab. It should autocomplete beginners tutorial for you. So the syntax is like this. You do ROS run, you do package name, and you do the node name. Okay. What was your node name? First one was talker, right? So write TA and press tab. It should break the similarity. Okay, and then press enter. Okay. I think I missed something. Let me just quickly look at it. Of course. can't read standard messages. Token year expected. Line 4 in Docker. Is it because I missed this line? Oh, okay. So there's a small thing that I missed when we copied it. Just add this line to your file on top. Both of the files, the listener file and the talker file, just add this to declare that you're using the Python for this. Okay, just add this top line in both of the files and come back to Catkin workspace. Okay. Okay, see. All right. So when I said two nodes communicate with each other via topic, right? There is one thing that I did not speak of. Is it's called ROS master. A ROS master is a, you can think of it as the YouTube platform. So every node, every topic needs to be registered with the ROS master before you run anything in ROS. Okay. So what you want to do is to make this happen is just press Alt Control T to fire up a new terminal. Okay, Alt Control T. That should open a new terminal and just write ROS core. Okay. When you write ROS core, it will open the it will run the ROS master right there. Okay. So my ROS master, which is basically this node, it's a master node. It is running using ROS core. So this is a command you want to run before running any other node. Okay, now going back to our previous node, in the Catkin workspace, what you want to do is write ROS run, beginners tutorials again. Okay, and then your Docker file. All good? Just run this. And it should start saying hello world. And I think that's the timestamp it is publishing. Yes, it is. Okay, now this Docker file is talking, but who is listening to it? There's no one listening yet. So what you want to do next is go open up a new terminal, Alt Control T. Okay, go to your Catkin workspace. All right, go to your Catkin workspace and do ROS run again. ROS run beginners tutorial. It should autocomplete with tab. And then now you want to run your listener.py, right? So when you run that, did I add that line to this? I did not. So make sure you add that top line to both of them. And now if I run it, this is my ROS master. This is my Docker, which is constantly talking. For some reason, I'm not able to open my, come on. Where is it? There it is. So I want to open my listener again. Okay. And now it should start listening. You see, there were two programs that we saw, a listener and a talker, and they are communicating the same message. If you notice, the first message that the listener started listening was the latest message that it published. So at any given instance, if you notice the time instance, it should practically be the same. So hello world, and look at this. It's basically the same time instance with maybe a little communication delay. Okay. So the two nodes are talking to each other. Now you want to see the structure as a graph, which I showed you earlier for another robotics application. Just fire up a new terminal, okay, and open this RQT graph. What I did was I ran RQT graph. There's some error messages for some reason. I'm going to ignore them.
because I get my graph. So run RQT graph, okay? And what you'll see here is there's a talker with some random number and there's a listener with some random number. Okay, and there is a topic called chatter. Please remember these names. There's a slash talker, there's a slash listener, and there is a slash chatter. Okay, so what is chatter here? Anyone? Yes, it is a topic. And who is talking here? The talker. And who is listening? The listener. Now you want to, there are more ways to see what's going on in ROS other than RQT graph. These functionality are basically given to you to analyze your system behavior. So first thing is there is a command called ROS topic. Very, very important. It has a lot of functionality built in, which we'll see in a bit. So let's reiterate over all the commands we have covered so far so that it's not getting overwhelming. Okay, so there was a catkin create pkg, right? Remember, to create a new package inside your catkin workspace. Then there was a catkin underscore make to make your package, right? And then there was a ROS run where you can basically run your node from any package. So the syntax, can anyone tell me the syntax of ROS run again? What does it expects? So ROS run space, what should I be giving next? Sorry? Perfect. Package name space. What's the next? So those are basically your nodes, right? So node name. All good. So and then there was a RQT underscore graph. Okay. These are all the commands we have covered so far. Now the new one that I'm talking about is ROS topic. And for ROS topic, so just to quickly see what functionality ROS topic has to offer, just write ROS topic and do tab. Okay, space tab, and you'll see these are all the things that you can do with ROS topic. One of them is list. So let me do ROS topic and then list. Okay, and then what you'll see basically here is your topic that is currently in the ROS system. Okay. Yes. Yes. I know. So for RQT graph, sorry that I did not mention. So if I open RQT graph, you will be by default shown this. Okay, just open nodes topic all and check everything in here. So I was talking about ROS topic, and if I do a list, I basically see 3 topics shown here. Why is that? Can anyone tell me? I know what chatter is. What are the other 2? Why are they here? Those are for ROS master. Okay, those are registered with the ROS master, and they will always be there as long as you're working on ROS 1. Okay, in ROS 2, which is a new version of ROS, there is no ROS master concept. The nodes communicate directly with each other. So make sure you know that when you're working with ROS 2. Otherwise, you'll try to run ROS core, it won't work. So now, as we saw, this command is very handy when you have a very huge package. Okay, you have a lots of nodes communicating over lots of topics. So you want to see what topic are available for me, okay, in the system. Now, this lists all the topic. What if I want to see what's going on this topic? What data is it getting? So what I need to do is I need to use echo. So remember, ROS topic, tab, you'll see all the commands. I just use list. Now I'm going to use echo, which is right here. Okay, I'm going to try echo. So ROS topic echo, and then I want to give my my topic name. Just write /ch tab, and it should complete. Okay, and then when I enter it, you see this is the data that is being passed on the chatter. Okay, make sense? So you can basically see from on any topic what data it is getting. All right, so is there anything else that we should be looking at? There is something called as ROS info, for which you need to give a topic name, of course. And it should show you that there is a publisher for this chatter topic that this node is publishing and this node is listening. So you can basically see everything using ROS topic. You don't, because when you have a large system, RQT graph won't make that much sense as this can make, ROS topic can make. And then you have few more things. I'm not going to cover everything here, but this HZ, which gives you the frequency at which the node is receiving those messages, okay? And there are more things. So, all right. Now what I'm going to do is I'm going to walk you through the code of listener and talker. So you actually understand how you create your nodes for publishing and subscribing and also creating your topics. Okay, let's go to both of these scripts. Listen very carefully because the next part of this tutorial will have a program that you will be completing a lot of steps from this code. Okay, first thing first, this is a Python program. Oh, remember to use this. It's called, what is this called? Shebang, right? Yeah, it's apparently necessary here. So make sure you have that, and then you have import ROS.py. Okay, since you're working with Python ROS. Okay, you can also write your nodes in C++, but since we are right now working with Python, so have your import ROS.py there, and then do from std message dot message import string. Now I'll explain in a bit why we have this. This is right now what we are going to use this for is basically the message that we are going to publish on the topic is going to be of this type of, it's going to be of string type. Okay, there's a very nice way of googling, of basically knowing what this message stands for. So just do ROS string. Okay, and you'll see that it belongs to this ROS message package. Okay, and the name is itself is capital S string. Okay, so that's why in your program, if you see, I imported it from std message dot message import string. Okay, std message might have other things as well. We want a message, and that message is particularly string, right? You can, now this string type has a field called data. Whatever the field, so this website is very helpful. Whenever you want to know about any standard ROS message, just Google that message space ROS, and you'll be shown a website like this. So this will basically tell you this kind of message will have all these fields. This one is very simple. It only has one field called data, but there can be many complicated, more complicated fields, which we'll see in the next part of the tutorial. All right, so we are done with our imports. Now let's first go through the talker, and then we'll go to the listener, because that would be easier for us. Okay, the first line. Okay, first of all, you guys need to know that this is how we define a function in Python. Okay, so I have a function called talker. Okay, okay, so for this tutorial, I do assume that you are kind of fairly familiar with Python. Okay, so this is how I define my Python function. I'm calling it talker. Okay, all the talker code will go inside this. Okay, now if I just create this function and leave it like that, nothing is going to happen. That's why I need to have an entry point for this program. This is the entry point. So just like in C++, you have main function. Here you declare in Python, you basically do something like this. So you declare okay, if main is declared like that, there's some exception handling done here, which is really not necessary right now, but just remember that you need to run your talker. Okay, you need to call your talker here. So now let's go through each line inside talker. The first line is basically telling that I'm a publisher. Okay, I'm going to publish something. What's the next question you should ask? What is the topic you're going to publish on, right? So that's the topic name. Okay, now this topic can only handle one kind of data. So you want to tell your code basically what kind of data you're going to publish on this topic, which is called string. In this case, we are basically passing a string on this topic. Okay, this is a queue size, which is basically a buffer, kind of a buffer. It will store up to 10 messages backlog. Okay, so far so good. This is how you create your publisher. So since we are doing Python, you need to call it using ROS.py. Okay, so ROS.py.publisher. So if I hover over this, it should basically give me all the fields. It's the name, and okay, there's a queue size. There's a data class, what kind of data you want to publish. Okay, the other fields we are not going to cover in this one. So this line is clear, very important, because this is where you declare that this is a publisher and all the other fields. This is where you initialize. You can have this reverse also. You can first initialize the node. So this is basically telling that this particular node that we are working on right now, it's called talker. Okay, you remember in RQT graph, we were able to see a name called talker and listener. It was because it was named talker by us. If I write something else here, right, it will appear with that name in my RQT graph or wherever you are seeing your nodes. And this anonymous equal to true has a meaning that if you run multiple instances of this code, ROS, it didn't used to be this way, but it's good that they added this. But so every time you run this node, it will be assigned a random kind of a name, so that because in ROS with the same name, you can only run one node at a time. So you cannot run two nodes of the same name at the same time. That's why you want to break the similarity in some way. That's where you put this anonymous equal to true. Okay, now if I run this node second time, it will be assigned some random value and it will still work. And both of my talkers will be talking. Okay, so that's the meaning of this anonymous equal to true. You can skip it, but then you cannot run the node again. So this is the name of my particular node. It will be there in both listener and talker. Okay, init node. And I'm calling this node as listener. Okay, again, anonymous equal to true. So there is a similarity between these two files. It's a listener and talker. Now in this one, as we saw, we need to have a publisher function, and then we declare the rate at which we want to publish. Okay, you have to decide at what rate you want to publish. So in this one, I'm publishing 10 messages per second. Okay, and then there is a loop. So this loop will run until you shut down that node. So ROS.py is shut down. This basically means you're shutting down that node. So it will keep running. As you saw, it's still talking and listening. So it's still running. It will not stop until I do Control C or some way kill the node. Okay, so this is where that part comes from. Inside this, you want to put all your basically publishing code, which is going to do this functionality, this continuous publishing. So basically you initialize your message. Okay, this is your message basically. So you write hello world. You remember, let me quickly open this. So let's look at this. This is the listener. Let me open the talker. Okay, that's the talker. Okay, do you see that message? Hello world, and then there's a number. What is that? That's basically hello world. You're writing a string here, hello world, and then a %s, which basically means that there is a string coming up next. This is good for now. I have created my string, but I'm not doing anything with it yet. Okay. Now what this is doing is let's ignore this line for now. Okay. Let's look at this message. You remember you declared your publisher as pub, right? That's the name of your publisher. When you created it, you named it as pub. Now what you want to do is call pub call a function called publish over pub. So pub.publish, and whatever this message that you're trying to pass goes inside that. Okay, this basically means the message that I created earlier is going to be published. And make sure that this message is of that same type that you declared. If you give another kind of message, it will throw you an error. Okay, since we have a string, it should work. And then you have a rate dot sleep. Basically, this makes sure that you're working at this rate. Okay, these are a few things that you need to keep in mind when you're writing nodes. Kind of think of it as a template. Okay, you declare your rate, and then you sleep. You call sleep to make sure that rate is being honored. Okay. All right, we understand these few lines of code for talker. Let's go through the listener. Okay. Any questions so far? Let me stop here and ask if there are any questions. Any questions? All good? Any confusion? Any question? No. Okay, awesome. Let's similarly go through each line of our listener. I have my ROS py, I have my next string import. All good. I'm importing standard message from this package. I'm importing a message called string. Now there's a slightly change in the listener template, which is basically saying whoever is subscribing, that template needs to follow this structure. Now notice that this is basically the same. I have my main and I call my listener, same as what when I was trying to call my talker here, right? Right? Make it simple. So that's much easier. All right. So what I have here is I have a listener. Anything? All good? Okay. Okay. So I call whenever this entry is invoked, this function is invoked. Sorry, this file is invoked. I go to my listener. What does listener do is initialize the node, same as what we did here. It creates a subscriber. Now, when you create a subscriber, what are the questions you need to ask yourself? What are you subscribing to? Just like when you were publishing, what topic you publish on. So you need to make sure you give a same topic that you mentioned here, because you want to listen to that topic, right? When you run this talker node, it is basically publishing on Chatter. If you give something else here, this will be listening to something else, but if it is not getting any data, you will not see anything, right? It will still work. I'm not saying that if you give Chatter 1 here, it will fail. It will still run, but it will not show you any data because Chatter 1 is not getting any data. You don't have a topic. Sorry, you don't have a node which is publishing to Chatter 1 basically. Now, this is done, and we declared our subscriber with Chatter. On Chatter, we have a message called string, and the slight change from publisher is that you have to have a callback here. Now, this callback basically is attached to your listener. Okay, every time there's a message on topic, this callback will be invoked. Does that make sense? This topic, sorry, this Chatter callback. I'm so sorry. The callback, that's confusing, will be invoked every time there is a message on your topic called Chatter. Okay, so I'm basically attaching this file, this Chatter topic to my callback, and I say just keep spinning. Okay, this is to make sure that your node is constantly running and this does not kill itself. If this kill itself, all your declaration are gone, right? So you want to make sure this kind of stays there. Okay, now you want to have a callback. Basically, you declare your callback. What this basically doing is, so log info is like a print statement in ROS. Okay, there are many other similar things. You can log error, I think, log warning, similar things, but we are going to log information. So think of this as a print. Okay, think of this as a print. So every time a callback is invoked, we print this data, how is this printed? So I get my ID, caller ID. So if I quickly open the listener here, you'll see there's a ID that I'm seeing here, right? It's not just I heard the data. That's fine, but there is a ID that I'm seeing here. That's how this is what is doing that. Okay, so what I'm doing is basically I'm basically appending all these strings together. This is a string. When I call this, I just get the ID of the caller, and then I attach I heard percentage whatever data this callback is receiving. Make sense? All good? So now it's almost complete. You have a talker which is constantly topping in a loop, okay, until it stops. And you have a listener which is constantly spinning over your callback and logging all the, printing all the data that it is listening to. Okay, all good. I know it's getting a little overwhelming, but be with me. The next part will make more sense because you now already know this. I'm going to keep this open for you guys so you can refer it. But now, since we have already covered this part, what I want you to do is stop both of these nodes. Okay. See, I stopped my talker and my listener is now blank because there is no data coming on the chatter, right? And with that, we are done with the first part of the tutorial. Let's quickly go to the next part, which is more interesting. And we are going to use a lot of concepts that we just covered here with the listener talker thing, right? So what I want you to do is go to source, and then you should see, okay, there should not be any package called Turtle Sim Cleaner in your VirtualBox yet. But what I want you to do is go to your source, catkin source, and do catkin create EKG, right? And I'm just going to copy it. So just write Turtle Sim Cleaner. Okay, you can name it whatever you want. That's your package. And just write ROS py. Okay, and let me make sure the message type that I'm using. Okay, so next thing I want you to do is just add geometry message, because we will be using this message just like we use standard message in the part 1 tutorial. We are going to use geometry messages here. So ROSPy and geometry messages. Okay, just create this, just run this command for me. Make sure you are in source folder though. All good. So make sure the package was created and you have the source folder inside that package. So just ls into your Turtle Sim Cleaner or whatever name you gave. Okay. All good. So what I want you to do is go back to your VS Code window. Okay. Just open the package that you just created. Okay. There should be a source folder. Just right click, new file. Okay. And give it a name called move straight.py. All right. All right. Give it that name and go back to the GitHub repo that you opened earlier. Go back to the home folder, ROS workshop, and there's a source folder here. Okay. There's a source folder. What I want you to do is grab the move straight code. Okay. There will be a lot of placeholders in this code, so it will not run right away. So I'm just going to copy it here. Okay. All good? Yes, move straight.py, copy that content inside a file called move_straight.py. which is placed under my newly created package. And there's a folder inside that source. Inside that is where you want to create your new file with the code that I just got copied from the GitHub repo. All good? So just for a minute, let's keep that on hold. And I want to show you a very quick demo of a simulator called Turtle Sim, which is installed with ROS. So what I want you to do is open a new terminal and do ROS run, write Turtle Sim, use tab. Okay. Turtle Sim. Okay. Do double tab, space double tab, and you should see all the nodes present inside this package. You remember, right? ROS run expects a package name first. So this is the package name which was installed when you install ROS. So it's stored somewhere in your system. We don't care. What you want to do is just peek at the nodes that are present inside there. Now, what you want to do is run the node called turtle sim underscore node. Okay, turtle sim underscore node. This line should be familiar to you by now. This is basically running a node called turtle sim underscore node from a package called turtle sim. All clear? Okay. If I run this, it should pop up a nice little simulator with a turtle inside there. Okay. There's a 2D space and there's a turtle. Now leave this window as is because this is basically running this simulation. Don't close this. It will close the turtle sim. Now what I want you to do is open another terminal. Open another empty terminal. Do you guys have this open? The turtle bot, turtle sim. Okay. So what I want you to do is now again do ROS run and do turtle sim. Okay, do tab, and you will see another node called teleop key. Okay, what I'm going to do is I'm going to add that node to my ROS run command. So basically now I'm running turtle teleop key from the turtle sim package. Okay, and I'm going to press enter, and it says use arrow key to move the turtle Q to quit. Try those arrow keys and you should see the turtle moving. Okay. So you can control the turtle rotation using the side arrow keys and the up and down to control the motion of the turtle. Okay. Okay. And it is kind of drawing a line. So when you press the front key, the up key once, the turtle has this whatever the program this is, it has an instruction to only run it for a certain distance. Okay, that's why it stops after a certain distance. That's how it's programmed internally, similar to rotation, which also rotates a certain amount and then stops. Okay, all good. So are you guys able to run the turtle? All of you are able to run the turtle? To some topic. Lower level modules will take that information, whatever the perception module published, and it could be that more than one topics, more than one nodes need this information, right? This cannot be done with sequential programming. Sequential programming, you get the data, you do something, and then you do something, and then you do something, right? It's not the way you need your system to be, right? This is kind of modular. You get the data, and then you basically you can have more than one subscriber getting that data and doing something or the other with that data. The functionality depends on the implementation, but they can be doing different things.
Based on that information, you just control the vehicle longitude, nothing else.
Of course, yes. It could be anything based on the implementation, yes.
Yeah, we're good.
Okay, so are you able to control the turtle? Okay, awesome. Now I'm going to press Q and stop the teleop key. This is basically a node for keyboard control. Okay, keyboard control for this turtle bot, turtle sim. Okay, so I'm going to leave this here and then go back to my move straight file. Okay, come back to this file. Now what I want you to do is open this file, and I already have a lot of code in here, but I want you to complete the fields missing and says create your something here or do something here. Okay, I want you to complete all those lines. So you have your ROS-PY, you have your geometry message. So let's quickly look into the geometry message twist. Okay, so I want to Google twist message in ROS. So I just do ROS twist. Okay, and the first link that you'll see is this. It's a geometry mess. This twist message is present inside this package, right? And it has these two fields. Now be careful. This is a vector of 3, right? There are two fields, linear and angular, but both are vector. You know what vector is, right? So when I say vector 3, it has 3 numbers inside the linear and 3 numbers inside angular. So what are those? So if I click this link further, you'll see there is a X, Y, and Z. Okay, there's some description of it. So this linear will have X, Y, and Z, and similarly this angular notation, the name again will have an X, Y, Z, and both are float 64, and these are also float 64. Now some of the information is given away right here. It says linear, which basically is contains 3 different X, Y, Z's, basically saying these are 3 different velocities in X, Y, and Z direction. So linear velocity in X, Y, and Z direction. Similarly, the angular is saying this is an angular velocity in X, Y, and Z direction. Although this depends on your implementation also, how you want to use it. But that's what the twist message is meant for, to publish velocity information in linear and angular region. Okay, now coming back to here, I get my package, my message twist from geometry message package, and this is already there. So this basically says that I'm importing a message. Now what I want you to do is initialize your node here. Okay, before that, so first of all, what does initializing a node means? What do you want to give it? Remember from the Docker, right? Write down a name for this node. You could name it anything.
So we're running it
Yes, it's kind of a, so this program, okay, I'm sorry about that. I did not explain what this program is supposed to do. This is basically asking your turtle to move straight. Okay, this program is supposed to move your turtle straight up to some distance that will be given by the user. Well, I'll explain that in a bit, but it will make the turtle bot move straight. Okay, so the turtle simulation that we just saw, it will basically connect to that turtle bot. Okay, that turtle. So just initialize your node. For this, you don't need any additional information other than what I just told you. Name it anything you want. Done?
Did you say initialize your node itself?
Yes. So rospy.init node. I have it here. So this string can be anything. As long as it is meaningful for this node. So just make a meaningful name, right? Maybe like a turtle straight. Okay, and then just make sure you have anonymous equal to true to break the similarity between multiple instances of that node. Okay, so you have completed that part. So let me also write that down. I'm just going to quickly copy it here and then name it turtle underscore straight. Okay, makes sense. Now next thing is create your publisher here. Okay, next thing is you want to create your publisher here. You remember when you're creating your publisher, what does it need for the first thing? Anyone? What is the first question you ask? The topic, right? When you are creating your publisher, what is the first question you ask? What is the topic you want to publish on, right? So to know that, in this case, we created our own subscriber and publisher, right? So we know when we knew our topic name, but for the turtle bot, we don't know it yet. But we have it running here. So what I'm going to do is I'm quickly going to open the terminal where I ran the turtle bot. Okay. So this is where I ran the ROS run turtle same turtle node, right? And I'm going to open a new terminal. Just make sure it is still running, okay? I'm going to open a new terminal, and what I'm going to write here is ROS topic. You see why this is handy here? Because I don't know my turtle sims topic name yet, where I'm going to publish my data. So I want to know that. What I do is I basically do ROS topic list. Okay. And since you guys have not worked on turtle sim, I'll let you know that this is the topic you want to publish your velocity information. So it basically says it CMD well, basically command velocity. Okay, this is the topic you want to publish your data on now. Remember this. So what I want you to next do is, in this field, create your publisher which publishes on this topic. Okay, so let me get this out of the way so that you can see the previous code. You know this is how you write your publisher, declare your publisher, right? ROS_publisher. So what I want you to do is use this complete name instead of chatter. Does that make sense? Can anyone tell me what will come as a second field instead of string? Sorry? Yes, what data? Yes. So ROS info, if I do this is a new command, and I do my turtle command well, okay. You see this? This is the message that this topic expects. The topic that we are looking at is this one, right? This is the kind of message it expects. Remember, in the previous type, in the listener talker one, we had standard message, and then we had a string here. So we wrote a string here. Now we have twist. So what should be there? Just put it that way. Okay. So now you know your topic name, and you know your message type. Remember, message type we are using is this one. It's not string anymore. So you want to make sure that you are giving this turtle linear and angular velocities, right? That's why we are doing all this stuff here. So make sure you create your ROS_publisher with the topic name as this and the message type as twist. Make sense? And then just have the queue size as saying 10. Yes. So now this topic, you're basically telling your publisher that you want to publish this message on turtle1 command well, right? This topic, but this topic expects this kind of message. You have to tell your publisher that information.
This is redefined. Yeah, like an object. Like a node.
Yeah, you can think of it that way. Okay, so did you create this part? Let me quickly write it for myself as well. So I'm going to name this as whatever the name of that topic is. Now we don't have a freedom to choose our own name here because the turtle sim has logged us to this topic. Okay, and then the next thing goes is twist. Cool. And then queue size. All good. We have our publisher here now. Very good. So let me explain the new next few lines since these are new. So here we have to declare our message type. This is basically creating an object of twist type, similar to, are you guys, have you guys worked on with classes in any programming language? So that's how you create your class object, right? So you're basically creating a twist kind of object and calling it a well message. You can name it anything you want. Okay, but let's keep it this way. The next few lines are very straightforward Pythonic lines. Okay, these are nothing but there's one which prints a line, says let's move your robot. So when I run this node, it will print this line. And then there's an input command, which is Python's way of taking command line input. Okay, so what it will do is it will print this message and wait for the user input. Okay, and whatever you input right there will be sent to speed. Okay, so basically you're initializing your speed from user. So we will be the one giving the speed. Similarly, type your distance. How long do you want the turtle to move? So you give a distance, and then there is a flag for true or false, whether you want to move forward or backward. Okay, very simple Pythonic things. We take 3 variables so that we can use it in the later part of the code. So checking if the movement is forward or backwards. Okay, you remember this message, this input that we just took. We check it. If it is true, okay, we keep our linear velocity in x. Okay, we're not going to move laterally, or we're not going to fly along z direction. The turtle cannot fly. It's a 2D environment anyway. So there will only be x velocity in x direction, and I'm making sure it's an absolute value. It's if a user enters negative value and says I want to move forward, I just take the absolute value of that input. Okay, so this in any case makes sure that the robot will move forward. Okay, makes sense. Similarly, if this is false, we want to move negative direction. Okay, we're going to give it a negative velocity backwards. All good. So you now know how to access the messages, basically parameters, the parameters that are inside that message, right? We just saw in the website that this geometry twist message has two kind of internal message, which are both vectors, linear and angular. And now we are going to use them. What I want you to do next in the next part is, so listen carefully. In the next part where I've just clicked, I want you guys to set everything else to 0, because we don't want to do anything else, right? So set it to 0 before we go ahead and publish this message. So are we clear till here? Do you have all these fields forced to 0? So let me quickly also do this. So it keeps me suggesting. I'll take that. I don't want to force x to 0 because I just initialize it with the speed. Okay, so far so good. Now comes the while loop part. Okay, that's where you are going to publish your data. There are a lot of things missing in this also. This one is done for you already. You take your time 0. Okay, you save it. You save your current time when you are on that line. Okay, you initialize your current distance to 0. Okay, to make sure that the turtle is not basically using some pre-declared distance. Okay, so now you start your loop. Let me just quickly do this. So next thing is you start another loop, okay, which is going to run until your distance is achieved. Okay, now this is going to be executed. All these inside instruction will be executed until your current distance, which you just initialized to 0, reaches the distance that user gives. So that is the input from the user. Okay. So next thing I want you guys to do is the message that you want to publish, is well message, right? I want you guys to write a command that actually will publish that message here. Okay. I have this for your reference. Just do that publishing, right? This is till now you only have prepared your message. You did not publish it. This is where you publish it. Easy. So all you need to do is basically your pub dot publish your well message. Sounds good. Then you get your next time, okay? And then you find, this formula already. Speed is equal to distance upon time, right? So you calculate the distance it must have moved with the speed you gave it and the time difference you encounter during that split second, right? During that time. So you get your time difference, you get your speed, which you just publish, and you get the distance it will move. Okay. Now this keeps on changing. This distance will keep on changing, and until it reaches a distance, this loop goes on. Okay, great. After the loop ends, so once this is done, once the robot has moved that much, you want to make sure that the robot is no longer moving. Okay. What you're going to do here is, I want you to change the message in such a way that you force the motion to stop, force the robot motion to stop, and then also publish that message at the end to make sure that the robot has stopped. Understand that? All good? All good? Awesome. Back there, all good? Perfection. So the next thing we want to do is, since we have this stopped, good. Open a terminal or just pull up your old terminal, okay? And I want you to go to Catkin workspace again, just to make sure everything is built, because you just created a new package, right? You want to make sure that Catkin knows about those packages. Just run it. Oh, I did not fill this, so let me do that part quickly. Okay, you want to force your velocity to 0, and you want to again publish that over here. Is this what you did? So in this one, you have reached your destination, so you don't want the node to be running. So this only comes when you want your node to be active, right? In this one, you remember it was constantly listening or publishing whatever the node was. But here, once you have reached the distance, you can stop. Okay. Okay, but the node will still be there because you still have this. ROS-PY is shut down. You're still inside this loop. This loop hasn't stopped yet. So you want to do Control C to stop your node, and that's where your node will stop. Okay. Okay. Just see, the thing is, there are several ways to do a similar thing. Just choose which one you want for your functionality. Now what we want to do is, again, let me quickly run the Catkin make. Okay, I have too many terminals open now. Lost track of it. It's this. Okay, so let me make it again. And I have my packages built 100%. I'm going to run ROS run. And then my package name. What's the package name? Turtle. My package name was Turtle Sim Cleaner. Sorry, I did not give the node name. So I have a move node, right? Move straight. .py. Okay, and I run it, and it keeps me. It comes to this input window. Let's move your robot. Input your speed. I'm going to do 5 maybe. Okay. Input your distance. I'm going to do maybe, let's say 10. Okay. And forward is equal to true. There you go. Okay. So So 10 apparently is too large for the space that we are here working on. But it does the job. It did go straight. And when it didn't, it couldn't, it just kind of slided there, okay? But if you give it like a nice distance, let me close this and run it again. And let me give a slower speed this time. And the distance will be like what? Okay. Before we do that again, the turtle is kind of in a bad position, right? So let me quickly rotate it so that it can. Okay, now it's good to go. You see how I open the teleop key node to control the robot with the keyboard. And now I'm going to run the straight again, speed 1 and distance of 2. Let's say 5 actually. Okay, and I'm going to start with 2. You see it runs slower, keeps running. Okay, there it stops. Okay, so whatever the units are in this space, it ran for 5 units. It runs for everyone? Now, do you see this, guys? Now there's a topic called turtle1 commandware, which we know, right? There's a turtle straight node that is publishing something on this topic, and turtle sim is listening to it. That's what we wanted, right? So understand that you can have more nodes. You can have multiple nodes publishing on the same topic also. It's a many-to-many relationship. Okay, you can have many topics, many nodes publishing on the one topic, and then many nodes listening to that topic. That is everything customizable. Yes. So nodes are always inside this oval. Okay, these are both nodes, and the rectangular thing is the topic. Yes, yes. So what next I want you guys to do is, there's one more file. In the repo, there's one more file called move rotate. Okay. There's another file called move rotate. I won't be helping you on this one. What I want you to do is copy this whole file, create another file called move_rotate in your turtle sim package that you created previously. Inside source folder, make sure you're inside source folder, create this file and complete it based on what you have learned so far. I'll help you. I'll walk around.
To be careful because of the time, because of the laptop.
I think we're done now. So
You think so?
I think so, yeah.
Okay, yeah, if you want to go ahead and say your goodbyes and then.
Is there anyone online? I don't know.
There are any questions? Only
Andy
online,
is
but I didn't
there,
see
so-
any questions.
Andy, do you have any questions? Can you hear me?
Listening for any
Yes, it is constantly listening on this command well.
command that is
So hold on, let me show you this one more thing quickly. That will make things more clear. So remember how I can have a teleop, right? So what if I run teleop now, since I already have a publisher in the graph? So let me run ROS run and then turtle sim. Okay, sorry, turtle sim, and then the teleop node name is. You don't have to remember all these nodes and package names. Just use tab all the time. Okay. So if I refresh this, you see that? You see that? There's a teleop turtle node appeared. So this teleop turtle, this name comes from your node initialization, right? When you initialize your ROS node, you give it a name, right? And give anonymous equal to true. For this one, anonymous equal to true is not there. That's why you don't see that random number around the node name. Okay, so you cannot run one more teleop because there is already one teleop in the system. Understood? That's the reason why I asked you to add anonymous equal to true, because it breaks the similarity. So are you guys working on the rotate part? So ask me any questions if you have. That's the last part. I wanted to cover one more thing, but I think we are well beyond time. We'll keep it for next time. So for the next tutorial, we'll be covering TurtleBot. The one that we just saw was TurtleSim. In the next tutorial, we'll be doing some simulation in ROS with TurtleBot. So this is like a 3D environment created. I can run some bunch of nodes and have the TurtleBot like robot running in this environment. We can also do mapping of that environment. There is a LiDAR on top of the TurtleBot. And when we run the TurtleBot around this environment, the LiDAR will show us the data in something called as ROS, which is ROS visualization. It's another package included with ROS, used for mainly visualization, visualizing your sensor data. Okay, it can also do some commands. And this is how the data looks like when it's saved. The map looks like when it's saved. And then you can also do some localization. You can, in ROS, you can give it the destination location and pose the TurtleBot should be, and the TurtleBot will navigate itself autonomously to that location and achieve that particular orientation that you give it. Right, so we'll cover all this in the next tutorial, more advanced things, but it's very interesting, of course. And later on, we can also work on autonomous racing simulators. There are a few. One of them our lab works on is F110. We have more visually appealing simulators. One of them is Arrival, crazy graphics. There's one simulator called Carla, based on Unreal, I think. So all of them are compatible with ROS. So we can like understand ROS in more detail with those simulator in the application of our interest, autonomous racing. Okay, so with that, I'm going to wrap up and hope that you have completed the TurtleBot rotation part. Thank you everyone for joining. I'll stop the recording here.